Okay, this is the first limitation. Second is, this method, log Pearson type 3, considers only one level of significance, that is 10% significance. It cannot consider 5 or 1% significance, which most of the outlier detection method can. Third point is, there is no provision for testing more than one outlier. That means you can identify only one outlier from your dataset, not more than that. The fourth limitation is, the table from where we identify the critical deviate, or rather K subscript n, where against different sample size the value of critical deviate is given. And as you can remember, this is the table which have the value of critical deviate, that is K subscript n, against sample size. So from 10 to 149, against each of the sample size the Kn value is given. But the problem is that this critical deviate is inconsistent and do not vary coherently with the sample size. Generally what happens in outlier detection method, the critical deviate, which determines whether our sample data is outlier or not, it varies or it increases with the increase in sample size. But this is not the case for log Pearson type 3 outlier detection method, the table that is used to identify critical deviate. So that is not increase the accuracy of detected outliers by this method. Now that is why a broader outlier test was developed by Spencer and McWane in the year of 1960. The name of this new method was given as Pearson type 3 outlier detection method. However, I am referring this method as Pearson type 3 outlier detection